So in this video, I'm going to do a couple of E2 elimination practice problems. And so here I've drawn 3 molecules, and I've also shown you which hydrogens that the nucleophile is going to attack. And so I drew the hydrogens as different colors. So the blue represents hydrogens that are blue are equivalent. So hydrogens that are of the same color are equivalent. So as you can see, the blue hydrogens are equivalent, and the green hydrogens are equivalent on each molecule. And so what you can do right now is you can try and draw the molecule that will form after an E2 elimination reaction occurs. And I'm telling you that it's going to be an E2 reaction. And additionally, what I've done is I've put little purple A's on the alpha on the alpha carbon, sorry. And so remember that the beta hydrogen must be removed, which is the carbon which is on the carbon that's next to the alpha carbon. And so let's start off with the molecule all the way on the left. So that carbon right there is a beta carbon, and that carbon right there is a beta carbon. Now we have to remember the orientation, because the beta hydrogen has to be anti to the leaving group, which is the bromine. And so on all 3 of these molecules, I've already identified which hydrogens will be taken. And so let's start off with the one all the way to the left. And so what's going to happen is these electrons from that hydrogen is going to move there to form a pi bond, and then that's going to kick the bromine out. And so below, I drew your final product. And as you can see, the pi bond is formed right there. So now let's move on to the next molecule. And so the blue hydrogen is going to be taken, and the electrons are going to form a pi bond there and kick the bromine out. So your final product would look like the molecule below. And you have a cis double bond or alkene, because as you notice, this would be a really good time for you to get your model kit, because that will really help. But as you can see, both of the methyl groups are pointing at you, so they both have solid wedges. And so this means that they're going to be on the same side of the double bond. And so now moving on to the final molecule, the pi bond is going to form there, and the bromine is going to leave, and you're going to end up with that molecule right below. And so according to Zaitsev's rule, we have to pick the major product, and that's going to be the most stable alkene. And so this molecule would be your major product. And so as you can see with E2 reactions, you have to really look at all of the different possibilities, and then generally you're just going to have to choose the best one. They're most likely just going to ask you for a major product. And so now let's do one more practice problem that's a little harder. And so take a look at that molecule and try and figure out what molecule would form after an E2 reaction. I've identified the leaving group as the chlorine, which is on the alpha carbon, and then I also identified 2 beta carbons for you to look at. This one's a little tricky. You might think there's 2 products, but remember, the beta hydrogen has to be anti to the leaving group, which is the chlorine. And that's really important for this. And so I'll give you a few seconds. You could just pause the video. And so to the right, I've drawn the 2 molecules that you may have potentially picked. And only one of them is the correct product, and let me explain why. So the top product, this one right there, on the beta carbon, you have 2 hydrogens, and one of them is anti to the leaving group. so this top product can form. However, the bottom one would only form if a hydrogen on this beta carbon was removed. However, with the dashed and solid wedges, you can see that this group right here is going to be anti to the leaving group, which is the chlorine, and there's no way to change that. And so as a result, this product down here would not form. And so this would be the correct product and the only product that could form from this E2 reaction. And once again, if you have a model kit, it would help to make a ring and put it in its most stable conformation to help you visualize this. And so I hope this video helped you. If it did, please give it a like and share it with your friends.